Welcome grade 7s, 8s or 9s to mathematics. Today we're looking at similarity. Some of you are doing similarity already in grade 7. Others are only starting with it in grade 8. But by the end of grade 8 you should have done it, and then you continue with this in grade 9. So what is similarity? Before we actually look at what is similarity, let's look at the words we're going to use when we're doing it. So, important definitions. A theorem, it has the possibility of being true, but proof is necessary. So, a theorem is something that you still need to prove. Okay, there has to be proof to it. Then, an argument is a set of one or more statements that you have made. An axiom is a principle that is accepted to be true, even though it cannot always be proven. However, in some cases it can be measured. Other theorems can be based on it. So axiom is something, it's usually information that is given to you. You can't always prove it to be true, so it doesn't even have to look at. However, in some cases you can measure it, and you can base a lot of other information upon that information that you've already got. A statement is a conclusion after something is proven. Okay. And the last one, what is proof? Proof is a set of logical statements that can consist of axioms, assumptions, arguments, and other theorems that leads to a final statement, a final conclusion. Okay. So what is similarity? It looks like this. So we have a shape and we copy it. Now, not only do we copy the exact shape, but we change its size. That's the only thing that differs. It's the same thing, but a different size. Same shape, different size. If we take a triangle, same shape, different size. Okay, so exactly the same shape, but a different size. Please remember, it can be turned around, it can be flipped, it can look different, but it's the same shape. Okay. So the first type of similarity we get is enlargement. So let's look at how it takes place. So we have one rectangle and it is copied and it is enlarged. Same thing, different size. We had a small one, it became bigger, it was enlarged. So when we look at these, we can always write it as a ratio to each other. So the way we determine the ratio is we determine it by looking at the length of the sides. So we look at this side and that one. Those are the two long sides, and we write it as a ratio. So we are going to say the new side over the old side, new length over the old one, 15 over 10, and we simplify it to simple form, 3 over 2. Don't go to mixed fractions, it's going to complicate life. Just leave it like this. Then we compare the second side. So we have 7.5, the new one over the old one, and we simplify it to 3 over 2. Now we've got a relationship between them, so we can write it as a ratio. This was the smaller rectangle to the bigger one, so the old one to the new one. And so our ratio, our enlargement ratio, was 2 to 3. So we don't always just get enlargements with sketches. We also get them in the form of text. So here they give me the enlargement factor is 2, or they give me the ratio. So let's do it with a triangle. Here we have one triangle. We copy it, we enlarge it. They tell us it's an enlargement factor of 2, and the ratio, all the ratios 1 to 2. So this one would be 1 and this one would be 2. So let's look at the length of our sides. We have 2,5 compared to a. Oh, that's a problem. We only have a. We don't actually have the value of a. So that's what we need to determine. So that's easy. We know that this was 1 to 2. So for every 1 I have here, I have to have 2 there. So I take a is equal to 2,5 times by my enlargement factor. Therefore, a is equal to 5 units. Let's look at another side. 10 compared to b. Oh goodness, I already have a b here. So I have to determine the value here. So b is 10 times 2, it gives me 20 units. Sometimes you have to determine the enlargement factor by using one side. So they can tell you that the two triangles are similar, and they can give you the value of two sides that are in relation to each other. Then you can determine the ratio of the two triangles and use that ratio to determine the other sides. So not only do we get enlargements, but we also get reductions. So that means when it becomes smaller. So we have a rectangle. This rectangle becomes smaller. And that side is 20, that side is 15. So we know that there's a relationship between those two. Again, we determine it, new over old, 15 over 20, 3 over 4. So now we've got the ratio. For every 4 we had here, we have 3 there. 10 over 7, 5. Let's see if the ratio is the same. There we write it as a fraction, simplify, 3 over 4. So our ratio, our reduction ratio, is 4 to 3. It became smaller. So that is reduction. So now, what else do we know about this? So this is, if they tell you that two triangles are similar, then we can assume certain information. We can assume that the corresponding angles are equal in both triangles. And what do they look like? So we have two triangles here. They look similar to each other, but we don't really know yet. If they tell us they are similar, then we can assume the following. Let's name this one M N O, that one A B C. So in this triangle, we can assume that this angle is the same as that one. So if they've given us triangle MNO is similar to triangle ABC, these three vertical lines refer to similarity. Okay, so they tell us these two triangles are similar, so the important part is to look here. Here's M first and A is first. So those two first ones are now equal to each other. That is what we can assume if they've given us this statement, that that angle is the same as that one. Next, they tell us that N is equal to B. So, hang on, before I go there, let's just look at the way we write it. So angle M is equal to angle A. So that those two you know. We don't always are lucky enough to get the two triangles. Sometimes they are into another triangle. So then you need to be more specific by referring to it with 3 letters. So angle M lies between N and O. So angle NMO and angle BAC. You always need to take the angle that you're busy working with is in the middle. Okay. The next one we look at is N. This angle N is equal to that angle B. So we write it as angle N is equal to angle B, or we write it in terms of the sides as well. So B and N falls between M and O, or O and M. You can write it both ways as long as N is in the middle. And B is between A and C, so A, B, C, or C, A, C, B, A. The next one is going to be O and C. Angle O is equal to angle C as given to you in that information there. And we can also write it as MON is equal to angle ACB. The middle one always refers to the one that you are working with. Okay. So the properties of similar triangles, the second one is corresponding sides are in proportion. Okay, what does that mean? Again, two triangles. They tell us that triangle MNO is similar to ABC. So what does that mean to us? That means that the first side MN is the same length as AB. Again, they've given us the information in these this little statement they've given us here. All the information we need is in there. So MN is the same length as AB. MN as AB. Next we're looking at, write it as a ratio. It's not the same length, it's in a ratio to each other. The next one we're looking at is NO. So the middle one and the last one, same as B and C. and we write it again as a ratio, first one to the second one. And the last one is side MO and AC. MO and AC is in a ratio to each other. So you can write it as MO or OM. It doesn't really matter the order in which you write it here. Usually we go alphabetical order. I wrote it not in alphabetical order just to show you it doesn't matter in which order you write it. And then because all three ratios are the same, we can write it as the first ratio is equal to the second ratio is equal to the third ratio. So this is information that you can assume because they've told you that those two triangles are similar. So the next question is, how do I write it out? So if they've given us the information, how do I go about writing my answer down to get my marks? So the order in which the letters of the angles are written are crucially important. You've seen as I've gone through the previous information that you use the information given to you in that little statement. So if they give you triangle M and O is similar to ABC, that has specific meaning. This has a different meaning, M and O similar to ACB. And this also gives you a different set of information. So the green angle here at angle M, firstly it refers to angle A, then it refers to angle C, and then it refers to angle B. So depending on how I write my statement, it refers to a different angle every time. So it's important to know which one is the correct one and which one you need to use. So what are the conditions for similarity? So what makes two triangles similar? We know information that we can get from similar triangles, but what makes them similar? The first condition is that you have to prove that corresponding angles are equal. So you need to prove 1, 2, 3 angles equal to each other. The next one you have to prove, or you can prove that corresponding sides are in proportion to each other. So you have to prove that side 1 and side 1 in one triangle and side 1 in the next triangle are equal to each other. Same for the second side and same for the third side. You have to prove that there's a corresponding side in each triangle that are equal to each other. How do I prove it? I use F, U, N, and X. Fun X is a way to prove it. You can also use other statements such as the exterior angle of a triangle is equal to the sum of the opposite interior angles. You can use statements like interior angles of a triangle always adds up to 180 degrees. Any of those geometrical statements and theorems and axioms that you've known about or have learned about, you are allowed to use now. These are not the only ones, there are more. So what will the proof look like? What would I need to write down to get my marks? I will need to write that down looking like the following. So let's see, they've given us two triangles. You always start with what you need to prove. So this will be what is in the question. In triangle PQR and triangle XYZ. So the order in which you write those will come from whatever they've given you in the question. Now we're looking at, we've got angle P and X. Those two need to be proven the same size. Q and Y needs to be proven the same size. R and Z needs to be proven the same size. This is if you're using angles. If you're using sides, you're going to do PQ equal to XY. So just follow me here. PQ equal to XY. QR equal to YZ. And PR equal to XZ, depending on what you use, angles or sides. You can't mix them up, it has to be either or. Remember to write it in the correct order as they've given to you. You have to give 3 statements with supporting reasons to prove similarity. So the first statement we're going to do is P equal to X, green equal to green. And you can use any mathematical axiom or reason to prove it. Next, you can prove Q and Q and Y, blue to blue. Again, with any reason. You have to give a reason. If you just write that, it means nothing. You will not even get half a mark. Next, you need to prove R and Z. So to prove R and Z, again, any mathematical axiom or reason. Now we've given 3 statements and we've given 3 reasons. Now we can say that we've proven what they've asked. How do we write that? We then say the reasons above can be based on any axiom or property that you know about. And then you say therefore. These 3 dots here means therefore. It means you are drawing a conclusion. You are concluding that the first triangle you look at is similar to the second triangle we're looking at, and you're writing them down in the order that you've proven it. P, then Q, then R, X, then Y, then Z. And because the first thing you've proven here was angles, the next time you also proved angles, and here you also proved angles. Therefore, your reasoning is angle, angle, angle. Okay, so an example. Firstly, the question, prove that triangle ABC is similar to ADE. So when you look at this, you already know that you have to prove A equal to A, B equal to D, and C equal to E. Now let's look at the triangles. So we have triangle ABC and we have triangle ADE, and also they've given you 2 parallel lines. So if we start with looking at what we need to prove, we are working in 2 triangles. We are working in the big yellow one, ABC and ADE. So in triangle ABC and triangle ADE, we have to prove A equal to A, so green, blue, B equal to D, and C equal to E in red. So firstly, we can see that A is the same in both triangles. That means it is a common angle. Therefore, the first thing we write down is angle A equal to A. It's a common angle. Next, we have to prove that B is equal to D, those 2 angles. Therefore, we can use fun X. So F in fun X is your corresponding angles. Therefore, B is equal to D. You have to write down that BC is parallel to DE. That is proof that has to be given because it's information that they gave to you that you used. Then E and C is equal to each other. Again, we're using the F in fun X. If you don't know fun X, please check out my video on types of angles. So C equal to E, corresponding angles. I did it in the order they've given it to me. Therefore, I can draw a conclusion that triangle ABC similar to ADE. And what did I prove? I proved an angle, another angle, and another angle equal to each other. Okay, so that is basically similarity for you. Similarity. I hope you enjoyed the video. Please comment or like, give me some feedback, and good luck with the next chapter. Have fun.